Hey everyone, and welcome to The Explainer. Today we are tearing into the STM32 primer. Now, on the surface, this fascinating little device from Resonance might look like a simple novelty, but as we're about to see, it actually acts as a brilliant Trojan horse for learning embedded systems. So let's dive right in and uncover what's really going on inside.
At first glance, you'd be entirely forgiven for thinking this colorful, circular device is just a fun, retro gaming gadget. Straight out of the box, it comes loaded with classic games like Maze and Breakout, all running on a bright color LCD screen. And you literally just tilt the device in your hands to move your character around, which I have to admit feels incredibly intuitive and playful.
But this brilliantly illustrates our main question for today. Is this just a toy to pass the time on a commute, or is it a gateway to hardcore 32-bit ARM programming? Because the truth is, beneath that translucent plastic casing lies a seriously capable evaluation and development package.
To answer that, here's our roadmap. First, we'll meet the STM32 primer, look inside the hardware, explore the CircleOS architecture, dive into memory and task scheduling, and finally, go from player to coder.
All right, Section 1. Meet the STM32 primer, a tactile introduction. Let's start with how you physically interact with the device straight out of the box.
The whole unboxing is a completely tactile experience, intentionally designed to break down the intimidation factor of raw electronics. There are no screws or complicated clips involved here. You simply grab the top and bottom halves of the case and pull them apart with your hands. Then, you fit a small battery jumper across 2 pins to connect the power supply, snap the case back shut, and just press the single push button to fire it up.
By forcing you to physically complete the circuit with that jumper before you can even play the pre-installed Maze game, the primer demystifies the electronics right from step 1. It's basically saying to you, look, this isn't magic, it's a circuit board, and you're the one in control.
Moving on to Section 2, inside the hardware, power disguised as play. Let's talk about the immense power actually hiding on that green circuit board.
The absolute brain of the operation here is an STM32 F103B6 microcontroller. We are not talking about a basic 8-bit chip. Actually, scratch that. It's not even close. This thing packs a 32-bit ARM Cortex-M CPU running at 72 MHz. It's got 128 kilobytes of flash program memory, 20 kilobytes of SRAM, and embedded communication peripherals like USB 2.0. It is a highly robust engine disguised as a plaything, capable of pushing a very impressive 90 Drstone MIPS of raw performance.
Alongside that processor, the board features a MEMS accelerometer, specifically the LIS3LV02DL. This is the magic component that lets you navigate menus and play games just by tilting the device in 3D space. It captures the physical orientation of the circuit board and instantly translates that movement into data the processor can use.
Section 3. The CircleOS architecture, the brains. Because having great hardware is one thing, but making it easy to use requires a custom embedded operating system.
CircleOS works in distinct stages. Upon a reset, it goes through an initialization stage to configure all that hardware we just talked about. Then it drops into an infinite loop, relying on a periodic SysTick interrupt. This interrupt acts exactly like a metronome, constantly waking the system up to check the buttons, pull the MEMS accelerometer, update the LCD, and run whatever application is currently active.
And what's really clever is how that SysTick scales. Whether the CPU is running at a low-power 18 MHz or cranked all the way up to its maximum of 72 MHz, the OS brilliantly maintains a strict ratio of 24,000. So, at 72 MHz, the SysTick fires exactly 3,000 times a second. This ensures perfectly smooth polling of the accelerometer and the displays, without ever bogging down the system.
Okay, Section 4, memory and task scheduling, room to grow. With the OS running quietly and efficiently in the background, we need to understand how the system maps out its memory.
If we want to move from playing to developing, we have to know where we can load our own applications. The memory map reveals exactly how the 128 kilobytes of flash and 20 kilobytes of RAM are divided up. The OS occupies the bottom section of the flash memory, leaving specific blocks stacked right above it for Application 1, Application 2, and so on. Similarly, a small sliver of the RAM is reserved for the OS, leaving the vast majority completely available for your active data.
So the crucial takeaway here is this. CircleOS is incredibly lightweight. It literally only takes up 24 kilobytes of your flash memory and just 4 kilobytes of your RAM. That leaves a massive 104 kilobytes of flash entirely free for you to schedule and run your own custom apps. You practically have the whole playground to yourself.
Finally,
Section 5. From Player to Coder. Taking Control. This brings us to the most exciting layer of the STM32 primer experience.
This is where we transition from merely playing the built-in games to actually writing, compiling, and running your own C code. To do this, you just use the included USB debug cable and the RIDE 7 software toolset. And the included examples make jumping into code ridiculously easy. Instead of starting from scratch, you can just take the default example, which simply toggles the primer's LED from green to red, and tweak it to add some audio feedback.
What is truly remarkable here is how simple the Circle OS libraries make hardware interaction. By dropping just this one single line of code, buzzer_set mode, buzzer_short beep, into your C file and pushing it to the device over USB, you've just reprogrammed the hardware. Your primer will now physically beep every single time the LED changes color. You've instantly bridged the gap between a line of text on your PC and a physical action in the real world. How cool is that?
Plus, you aren't just limited to running one app at a time. You can easily manage all your custom programs directly from your PC using the included Circle Manager utility. Right from your command line, you just use L to list all the apps currently loaded on your device, A to add a new compiled object file you just wrote, or E to erase an app when you need to free up some space. It is a full-fledged deployment environment right at your fingertips.
So, we've seen how the STM32 primer effortlessly bridges the gap between a playful handheld gadget and a highly capable serious coding environment. By making the hardware completely accessible and providing a lightweight OS that handles all the heavy lifting of peripheral management, it empowers you to just focus on creativity. So, armed with full access to 3D tilt controls, a color LCD, and a blazing fast 32-bit ARM core, what will you build next? Thanks for joining me for this explainer, and I really hope this sparks your curiosity to dive in and start coding.